All right, so we looked at intersecting lines in the last section, where we're looking at pretty much the questions were all in 2D, and we're still looking in 2D, but we're looking at lines have possible classifications when we're looking in 2 dimensions. There are 3 different ways lines can interact, and that is if the lines have an angle between them, they're going to intersect because they go on for an infinite amount of time. So when we have intersecting lines, we have one point of intersection, we have a unique solution. Parallel lines, we've got these go on forever and never meet, so they've got no solutions. And then we've got coincident lines. These are when the line are the same, and sometimes they don't look the same, and there's infinitely many solutions. Now, you need to take careful note here because this section will build onto the next bit. So in the last section, we went through solving simultaneous equations. There is a few different ways to do these particular exercises. Now, this first one, you can solve it simultaneously, and I've just included, I just want you to know that, like, I'll try and change this on the page in the notes afterwards, but pretty much the easiest way once we get simultaneous equations is go equation in our calculator, simultaneous, 2 unknowns, we put it in. So I've put in this, I've just changed page, that's annoying. Where are we? Relationship between lines. We put the function in here, and then we press solve and get it. So this particular function here is going to have an intersection point of 5 and -2. But I'm going to have to quickly solve it because we are going to want to do it. This is talking about doing it as a matrix instead, where we do matrix operations. Sorry, I've got caught up in explaining the line part as opposed to this. So we can break this into a matrix which is 2, 3, 5, and 4. And this here, we then put a line there, and it equals 4 and 17. So this is sort of a bit different, this augmented matrix. And what it means is we can actually do like a row operation here. So in this particular one, we've got, well, if I'm looking at the example because I want to keep it lined up with that. In the textbook, what they've done is they've gone, well, let's times row 1 by 5 minus 2 row 2, and this will give us, this will become row 2. Now, that might not make sense yet, but what this means is here, this is going to become row 2. So this will become row 2 down here. So nothing's happening to the top row. So we're looking at 2, 3, and 4. And then this next one here we're looking at will be 5 row 1 is 10 minus 2 times 10 is 0. Okay, and then we've got in the next one here, we've got 5 times 3 is 15 minus 8 is going to give us 7. And then we've got 4 times 5 is 20 minus 2 times 17 is -14. Yeah, that's -34 plus 20, so -14. Now, this augmented row matrix, this row represents Y, this row represents X here. So we've got now in this one, we've got, well, 7Y equals -14. Therefore, Y equals -2, 14 divided by 7. We can then sub this in the row above it, and I'm just a bit short on room here, so I'm going to just do this as 2 plus 3 times -2 equals 4. 2x, which means we're going to have 2x equals 10, because we've got -6, so we add 6 to both sides, and then we get x equals 5. Now, if we jump down to my calculator screen here, you can see that is the way we solve it. And I've also done it as a matrix operation, but a little bit different there. Okay, now this here is an intersecting line. So this, let me just change color. We're looking at this one here is intersecting because we get a unique point out of it, which is one unique point. Now this next one I've made up. I've tried to do it in a way that we can see it here. So you can see here that it's they've got the same slope, but they've got different y-intercepts. So these lines would be parallel, and I've done that deliberately so we get to see this. Okay, and so what this will mean, I'm just going to move everything over a touch so we can work straight down. Okay, what this means here is I'm going to rearrange this just to be a little bit easier to do. We're going to have, obviously, we do x first, so negative 3x plus y, negative 3x plus y equals 10 and negative 6. The reason I've done this is we're going to see what this looks like in the augmented matrix. We've got negative 3 and 1, negative 3, 1, and we've got 10 and negative 6. Now, when we do this solve here, this next solve, we're going to go, well, row 2 take row 1 becomes row 2, which is part of our rules. So I didn't sort of go through them before. I will later. And so this now becomes negative 3, 1, and 10, like we've just done. But we get 0, 0, and then 10 take negative 6 is going to give us 16. And so we can see here that these values are never going to meet here. We've got in this space, because we've got a constant here, 0x, 0y equals 16. This just doesn't work. So 0 plus, if I write this out, 0x plus 0y equals 16. That's what it's saying here, and that doesn't work. So that's why this one here, no solutions. Therefore, it's parallel. Okay, this next one here we're looking at, I've picked this because this is sort of how a lot of the time we see it. These are actually the same line, and we would notice that here. So we would do our augmented matrix, and we've got 2, 3, and 4. And then we've got 1, 3 on 2, and 2. And in this space, we would go, well, let's do, I shouldn't do a minus there. We're going to do, so let's think about, we want to get rid of this one here. So we're going to go negative 2 times row 2 plus row 1 becomes row 2. And so that means we get 2, 3, 4. Okay, we get here negative 2 times 1 gives us negative 2, plus 2 gives us 0. We get a 0 there. 3 on 2 times negative 2 gives us negative 3, plus 3 gives us 0. And then we've got 2 times negative 2 gives us negative 4, plus 4 gives us 0. Now you'll notice here, the only difference is this one here, this 16, has a constant there, so it doesn't work. But this one here, 0x plus 0y equals 0, has infinite solutions. Therefore, same line, or lines are coincident. I'm going to stop there because I just want to keep that video short. I've just messed around with, at the bottom here, some of those ways we can do it. I've also got sort of specified up here, back from matrices last year, we solved things like this. It's in our discussion at the end.